Assalamualaikum warahmatullahi wabarakatuh. Okay, for part number 4, this part will be the last part for chapter number 1, where we want to discuss what I call the problem solving techniques. So this technique we will use or we will implement throughout this subject. So this technique actually is the general technique that can be used to solve the problem involved with chapter number 1 until chapter number 6 in thermodynamic 1. Okay, so the purpose of this problem solving technique, actually you want to reduce the solution of the complicated problems. Okay, so we want to reduce the solution, try to get to find or to identify the easy way in order to solve the problem involved with thermodynamic. Okay, let's say for example you want to solve this kind of question, for example simple question. Okay, so the example of the question is, the basic barometer can be used to measure the height of a building. If the barometer readings at the top and at the bottom of the building are 675 mm Hg and 695 mm Hg respectively, determine the height of the building. So this is the question. So we want to try to solve the question by using a problem solving technique. First step is step number 1 is the problem statement. So where you need to state the problem, you need to state the key information given, and also the quantities that you need to be calculated, or the quantities that need to be found. Okay, for example, for this case, the data given is the pressure at the top of the building in terms of barometer reading 675 mm Hg, and also the bottom pressure, the pressure at the bottom of the building, where we have barometer reading 695 mm Hg, and the answer required is the answer for the height of the building, H build. Okay, H of the building. So we want to calculate the value of H for the building. Okay, that's step number 1. Step number 2, you need to draw the schematic diagram in order to get the clear pictures about the problems. Okay, so you need to draw a sketch of the physical system and list the relevant information on the figure. So you need to draw and then put whatever data given that you know, and try also put the parameter that you did not know yet. Okay, for example, just draw a building. So we have the building that's surrounded by air. Okay, so we want to determine the height of the building, H building, and the data given is the bottom pressure 695 millimeter Hg, and the pressure at the top 675 millimeter Hg. Okay, that's step number 2. Step number 3, make assumption and also approximation. So you need to state any assumption and approximation to simplify the problem or try to solve the missing value that required by the problem. Okay, for example, for this case, we assume that the constant density of air with the height, constant density. So throughout the problem, I call any point in the air will have the same density. So that's our assumption. And we don't have any value given for the density for the mercury. Okay, and also the density for the air, and also the value of gravitational acceleration. So what we have to do, so need to make assumption by referring what I call the reliable data to find the density of the mercury and also air from the table or from the reliable source. So let's say we already get the value of density of air, where density of air is 1.18 kg per meter cubic, and density for mercury is equal to 13,600 kilogram per meter cubic, and as a gravitational acceleration equal to 9.81 meter per second square. Okay, so that's the assumption and also the approximation that we have done for step number 3. Step number 4, we need to identify the physical law that need to be used. So we need to apply all the relevant basic physical law and principle and simplify them based on the assumption made. So we identify the formula or the equation or the principle, and then try to simplify according to the data given in the problem. Okay, so for example, for this case, we apply the pressure difference of fluid principle, where we have delta P equal to P2 minus P1 equal to rho G delta Z that we have learned before. Okay, that's step number 4. Step number 5, in terms of properties, so you need to determine the unknown properties at known state to solve the problem from the properties, relations, or tables. So you need to determine, by using the data given, you need to determine whatever unknown properties before you calculate what we call the final answer. Okay, so based on the principle, so we know that bottom pressure P bottom equal to rho Hg multiplied by G multiplied by Hg, the height of the column of the barometer. Okay, and the individual pressure P top equal to rho Hg multiplied by G multiplied by Hg, the height of the mercury at the barometer. Okay, next, after we already identify what we call the equation and also the important properties, so next step number 6 will be the calculation. So substitute the known quantities into the simplified relations and perform the calculation to determine the unknowns. So for this case, okay, based on the what we call the pressure difference principle, so we will have what we call bottom pressure minus top pressure equal to rho air multiplied by GH building, and then rearrange the equation. So you will get H building, the height of the building will be P bottom pressure minus P top pressure divided by rho air, density of air, multiplied by G. Okay, step number 6. Step number 7, reasoning, verification, also discussion. So you need to check to make sure that the results obtained are reasonable and verify the validity of the questionable assumptions. Repeat the calculation that resulted in unreasonable value. So if after we check, so we look at the what we call the solution and also the answer. Okay, if the solution and also the answer is reasonable, so we can accept the answer. So the step or the solution already completed. But if we look at the solution, also the what we call the answer is not logic or unreasonable, so we need to recheck and also recalculate what we call the recalculate the solution. Okay, so that's 7th step in our problem solving technique. So you need to do these steps to answer whatever question involving thermodynamic in this subject. Okay, end of chapter number 1. So that's all for chapter number 1. So I hope you will understand the content, and also at least you need to know, you understand the basic principle of the thermodynamic. Okay, so if you have any problem or any question, let me know. You can ask through WhatsApp or whatever medium that available. Okay, that's all. Thank you. Assalamualaikum.